All right, what's up, everyone? Today we are going to start our new unit on solving inequalities. So, before we get started, we're going to do a little recap. So, previously, we've been studying solving equations. That's what we spent all last chapter doing, and those typically have one solution or value that makes the equation true. Now, we did talk about exceptions to that, but for the where we had infinitely many solutions or we had no solutions, but typically they had one value. Usually we're talking about the variable x that makes the equation true. Okay, today we're going to talk about inequalities though, and an inequality, you'll remember, has a range of values or a solution set that make the inequality true. So it's going to have this solution set that, or this range of values that can work for the inequality and make a true statement out of it instead of just one value. All right, so I'm going to show you kind of what these symbols look like, and just to jog your memory, and then we'll look at an example of each as well. So greater than symbol means I have something bigger. This is the greater than symbol, and it's opening towards the thing that has the highest value. So bigger opens towards bigger, and then the right hand side, whatever's over there would be smaller. And if I were drawing a number line, it would have an arrow that goes this direction, because we know when you think about number lines that they increase or things get larger going to the right hand side. Now the left hand symbol is going to look like this, where you have a smaller number on the left, bigger number on the right. And then this would look like here, right, where I would have it open, again, open circle, and then the smaller values would be going to the left. Now, for greater than or equal to, less than or equal to, the symbols are facing the, oops, that's what we get for trying to talk and write at the same time. Oh no, it's always so embarrassing when I scribble erase, that's my erase. The symbols can be facing the same direction as before, but you're also going to have this line underneath it for equal to. Bigger, equal, greater than or equal to, smaller, right? So greater than or equal to means that it could be bigger, but it also, right, it could be the same, right? They can be equal, right? So, and then smaller, less than or equal to, bigger. All right, so if I were to draw a number line here and show you what these look like. So for greater than or equal to, we'd have a closed circle because we're now including that boundary value. Moving to the right. And then for less than or equal to, again, closed circle because we're including that boundary value. And then it's kind of a sloppy arrow. All right, there you go. All right, so let's see some examples. So you notice here that I'm just using x and 2, keeping that the same so that we can see the difference between those symbols here. All right, so I'm going to go ahead and just number all of these Number lines 1, 2, 3. Let's choose right there in the middle. We can kind of see what's going on. All right, so go ahead and see. Actually, this is a great thing for you to try out. See if you can go ahead and graph these. All right, so here we've got 2 is greater, or x is greater than 2. So we've got 2 here. We want the values that are also bigger than 2, so we're going to go this direction. All right, then x is less than 2. Again, we're not including 2. We just want numbers that are smaller than 2. So we've got 2 here. Less than 2. All right, so now x is greater than or equal to 2. We're going to have in closed circle at 2. We want values bigger than 2. And then here, we want values smaller than 2 or equal to 2. Like so. All right. So let's go ahead and graph the following here. So I've got x is greater than 4. Now, again, this means we're looking at strictly all right, strictly. Oh my goodness, I just spelled that wrong twice. Sorry, my dog is barking. I'm trying to think at the same time. So strictly greater than means we do not. Oh, see how I change that? Do not include the boundary value. All right, so I'm going to put an open circle here at 4 because we're not including 4. And then we're going to go bigger than 4 because it says our x's are bigger than 4. So pointing to the right. All right, next is x is less than 2. So this tells me that we're going to have a closed circle since we have that equal to. So at -2, I'm going to make a closed circle, and then we want x's that are smaller than that. So we'll be going this direction. All right, go ahead and flip the page. Couple more here. Oh geez, what just happened there? Alrighty, so go ahead and graph that first one in example 2. So go ahead, graph this guy right here. Let me know what you think. Alright, so we've got x's greater than 3. So at 3, I'm making myself a nice closed circle, and I want values greater than 3. This one over here, ooh, it's a little bit tricky, so you'll notice that this one here, we are going to have to do a little bit more thinking because the variable is on the right, and we haven't seen that yet, so we might have to think through what's going on here. Okay, so this is saying that 5, because it's opening towards 5, right? Or it's saying 5 is greater, right, than x. It says 5 is bigger than our x values. So we want values smaller than 5. So if it helps you to kind of rewrite that right now, that's totally fine. So this is the same thing as saying that x is less than 5. So notice how I moved, right? X is now on the left, 5 is on the right, but I had to change the direction of the symbol so that it still has the same meaning, right? The x's are smaller. All right, so at 5, I'm going to put an open circle, right? Because it's strictly strictly less than. We want values smaller. All right. Now we've got x is greater than 1. This can be an open circle at 1. Values to the right are bigger. All right, and then last but not least, we got another one of those tricky ones here, right? So we're gonna have to stop and think. If you want to, you can rewrite this. We want our x's to be bigger than -4. So I'm going to go to -4 and leave an open circle like so. And extend that out to the right. All right, so now we're going to come to some word problems. And one thing that we're going to have to do, though, is define our variables. So if I'm teaching you, and I've got a word problem here, and I decide that I'm going to use a variable, we have to tell the reader, like whether it's your teacher or even you later coming back to your notes or your friend, what it is we're talking about when you use that variable. All right, so I'll show you what this looks like. I have this problem where I'm going to write an inequality to represent it. The suitcase needs to weigh less than 500 pounds. Okay, so what we're going to do is, because we're talking about the weight, I think I'm going to use the letter W as my variable. So I'm going to say, let W be the weight of the suitcase in pounds. All right, so then I've got W, my suitcase, and it has to be less than 50 pounds, like so. All right, Mrs. Trismar, that's me, needs to consume at least, wait, that's a helpful word there, at least 600 milligrams of sodium per hour while running a marathon. All right, so I'm going to use the letter S for sodium. So we're going to say let S be the amount of sodium in milligrams. And I'll say S is greater than or equal to, because it needs to be at least. So the bare minimum, 600 milligrams, but greater than that is even better, 600. All right, and then this one was written by my husband. You can spend $25 or less at the coffee shop this week. He's giving me a little budget. right? So let's say, let C be the amount of money spent on coffee in, right, American dollars. All right, so you've got C has to be less than or equal to 25. Realized I wanted these guys to be blue, so I'm going to change that because why not? All right, so I hope that you found this helpful in your journey for jogging your memory about inequalities, and I'll see you in the next one. Bye.